Okay, so I got up to um, cool enough to form particles, and then I kind of missed
Not
the bit.
particles, atoms. The
Atoms.
particles were there.
Yeah, the atoms. Okay, so cool enough to do atoms, and then I missed the bit where you started talking about really cool stuff just now. So
So once
sorry.
once atoms are formed, the fog disappears and then light goes away. So, but at that moment, hydrogen was about 3,000 degrees Celsius. So
Okay.
that was a long time ago. So you have this hot gas, 3,000 degrees. It continued to expand, and as it expands, as we said, expanding things cool down.
Okay.
And so the universe expanded, and what was 3,000 degrees when the fog went away, it's now cooled off to the point where it's minus 270 degrees Celsius now. So super incredibly cold.
Yep.
Now, you know if you have a piece of steel, a hot steel, it glows red. And
Yep.
if you make it hotter, it glows blue,
Yeah. Yeah.
right?
Yeah.
If you turn the temperature of it down, eventually it stops glowing so that you can see it, but you'll still
Yep.
burn your hand, right?
Yep.
So it's
Yep.
giving off infrared.
Yep.
If you
Yep.
cool it more, it will change the light it emits to different kinds of light. And
Yep.
if something is minus 270 Celsius, it
Yep.
will not give off light, it won't give off infrared, but it will give off radio waves.
I see. Okay.
And so that's what these guys saw back in 1964. They saw the radio waves of this very cool thing, but what that was the leftover of the Big Bang that used to be hot, but it cooled over billions of years.
Okay. I'm with you. So how did they know that it was that?
Well, they didn't to begin with. In fact, they went, what the fuck? And so they called up some guys at Princeton who
Yep.
were actually trying to build an experiment to look for the radio waves of the Big Bang. And the guys at Princeton said, oh, damn, you got there first. They were very
Oh
sad.
wow. Okay. Okay.
So
Okay.
these two guys by accident got Nobel Prizes. Uh,
Interesting. Cool.
yeah. But then, so the scientists at Princeton said that the this thing is called a black body. So if you take an object that's perfectly black, so
Yep.
that it absorbs all the light that hits it,
Yep.
it gives off a characteristic spectrum. And so if you look at this radio waves from space, it's not just one frequency, it's a lot of frequencies. And if you measure the frequencies, you find out that it's a perfect uh, spectrum for a black body. And the temperature is minus 270 Celsius. And so that was the prediction, from what the Big Bang Theory would do, is that it should be a big black body. They weren't quite sure what the temperature should be. There were other reasons from the 1950s where they kind of guessed what it might be, but it was only then when they actually proved what it was.
Okay.
And so that's how, that's actually seeing the fireball of the Big Bang cool down.
Yeah, I see. Very interesting. So, with these guys from Princeton, um, I mean, I guess I'm gonna end up going into it a bit more, but do I have a question for that at the moment? I probably don't at the moment. There is a question I think that's brewing in my head, but I don't I don't think I know enough to formulate it right. So,
Yeah.
um, I'm just thinking, what did they know that made them look for that radiation, the low end spectrum radiation stuff? Um, what was the thing that made them look for that?
Well, it's a prediction of the Big Bang. If the universe was smaller, hotter, it was hot enough to glow in the early days.
Yeah,
It expanded. They knew if it expanded, it would cool off. And so they were looking for that leftover heat of the Big Bang. And they knew that in these modern days, it wouldn't be visible light, it wouldn't be infrared light, it would be either radio waves or microwaves or whatever. So they just went looking for it.
Okay, wait. So I guess one thing I'm not sure of right now is, so did people know how old the universe was, or did they assume already how old the universe was at this point, or not?
There, they knew to a degree
Okay.
because they knew a lot of things. For instance, you can look at the radioactivity in the Earth, and
Yep.
by that time they knew that the Earth was already 4 or 5 billion years old. So obviously the universe has to be older than that. By then they would look at certain stars, and they knew a fair bit about how stars, the nuclear processes that make stars happen.
Yep.
So you could look out. I mean, there are billions of stars out there, and so they saw that some stars could not be what we see if there had not been a lot of time to make them happen. And
Okay.
so I can't tell you off the top of my head what the range of years people thought the universe was in the
Yep.
1960s, but I seem to recall in the back of my head, people were arguing about sort of 10 to 20 billion years. So they didn't, they don't know it as accurately as we know now, but they
Cool.
knew it wasn't 100,000. They knew it wasn't a million. They knew 10-ish billion was about right, but their
Cool.
uncertainties were pretty crappy.
Cool. Cool. Yeah. No. It's just. I was just. I was just wondering. Um. Okay. Cool. So we're up to speed on